I'd like to do number 20. Problem 21 is a sign for homework, and so if you know how to do this one, then you can do the one for homework, no problem. This one says they give you some information. They say you're given that sine of A, so A is some angle. Sine of A is 2 over 3. And you're also given that cosine of B is negative 1/4. So they're told these values. Now, they say A and B are in the interval pi over 2 to pi. And I'll talk about that in a moment. You're also asked, so with this information, you need to find sine of A plus B and cosine of A minus B. Now, the statement here that A and B are in this interval, what that's really saying is A and B are things bigger than pi over 2 but smaller than pi. So A and B are in quadrant 2, okay? Because the north pole is pi over 2 and the west pole here is angle pi. So that's the first thing to notice. They're basically saying that these two angles are in quadrant 2. That'll be important in a moment. The rest of this is just other information that we're going to have to use in the middle of solving this problem. So the first natural thing to do is to expand sine of A plus B and cosine of A plus A minus B in terms of the the identities, these things. So I'm actually going to use the full sheet of paper here just to save some room. So so let me just point them out to you now and then cover them up. So sine of A plus B, we'll use this formula with alpha equal A and beta equal B. And for cosine of A minus B, we'll use this formula with alpha equal A and beta equal B. Okay? So I'm going to move those off camera, but I'm going to put them on my desk so that I can see them. And we will now calculate sine of A plus B. And this is going to be sine of A cosine B plus cosine A sine B. And similarly, cosine of A minus B is cosine A cosine B plus sine A sine B. Now, I can fill some of these things in, right? I can say that based on the given information up here, sine of A is 2/3. So this is 2/3 times cosine of B, which is negative 1/4. But I don't know cosine A or sine B. So I can simplify at least that far. With the second one as well, I can do similarly. I don't know cosine A, but I do know cosine B, so I get negative 1/4 cosine B. And I do know sine A, but I do not know sine B, so I get plus 2/3 sine B. Now, the remaining part of this problem is finding out what the values of sine A, what sine of B and cosine of A are. Did I make a typo here? Cosine, yeah, this is cosine of A. My apologies. So, okay, so how do we do this? Well, that's where this quadrant information and this given information will become useful. We essentially have to draw triangles. So, let's do the first one. So if I knew that sine of A was 2/3 and I wanted to find what cosine of A is, well, then I would draw a triangle. And we've done this before. So I'll draw a triangle that satisfies the fact that sine of A is 2/3. So here's the angle A. Sine is the opposite, which is across, which I'll call 2, and the hypotenuse is 3. Now remember, triangles do not get negative side lengths. Whether it's a plus or a minus sign comes entirely from the quadrant information, and we'll decide that at the end. Now in this, the bottom leg is unknown, so I'm left with, by the Pythagorean theorem, I'll say that question mark squared plus 2 squared is 3 squared. In other words, question mark squared is 9 minus 4, so question mark is root 5. Oh, sorry, I should have brought that up a little bit. My bad. The next one will be okay. Now from this I can conclude that cosine of A, which is one of those values I need, is really the negative of the adjacent over the hypotenuse, root 5 over 3. Now why is it negative? Has to do with the quadrant. Remember, if I'm in quadrant 2, I'm left of the vertical line, so my x's are negative. And over here, that means cosine being x's, first coordinates, it's also negative. So we get negative root 5 over 3. Now, similarly, we have to calculate sine of b. Again, not a problem. So that is a triangle. So now we use the other information we have. The other information we had was here, that cosine of b was negative 1/4. But again, I can't make side lengths negative, so I'll make the adjacent 1, the hypotenuse 4, and call this question mark. When I do this, I'll end up with Pythagorean theorem again. I'll get 1 squared plus question mark squared is 4 squared, which leads me to the conclusion that question mark must be square root of 15. Because 4 squared is 16, and subtracting 1 gives me 15, then taking the square root gives me square root of 15. Therefore, and those 3 dots means therefore, if in logic, if you didn't know that, the sine of b is the positive of square root of 15 over 4. So we have now the 2 unknown trig functions that we needed for our calculation. So there they are. And I'll just copy them over as we need now. So therefore, sine of a plus b. Now from our calculation up here, 2 times 1 and 3 times 4 gives me negative 2/12. You could simplify that to 1/6 if you like, plus cosine A, which is this negative square root of 5 over 3, times sine of b, which is this expression, this square root of 15 over 4. So what do I get? I get negative 1/6. I like to simplify them. Square root of 5 times square root of 15. 15 times 5 is, I forget. I can do it in my head, but I'd rather not make a mistake. 15 times 5 is 75, so I could write this as negative square root of 75 over 12. And as far as I'm concerned, that's a perfectly good answer. You could take the 5 times the root 5 from the root 15 and rewrite it as 5 root 3. So you could get negative 1/6 minus 5 root 3 over 12. Either answer is acceptable as far as I'm concerned, but that's sine of a plus b. Similarly, cosine of a minus b is, and that comes from here now, negative 1/4, we had that from earlier, times the cosine of a, which we have here as negative root 5 over 3, plus 2/3 times the sine of b, which we have here as root 15 over 4. And I can simplify that a little bit. Negative and negative is a positive. So I'll get root 5 over 12 plus the 2 and the 2 are going to cancel a little bit. I could rewrite this as root 15 over 6, I believe. And you could do a little more with that maybe, but as far as I'm concerned, that's a perfectly valid final answer. Now, one thing you don't want to do is you don't want to take this and find the inverse and solve it. So say A is inverse sine of 2/3. I mean, you could do that, but what I'm looking for in a problem like this are perfect answers. I don't want numerical decimal answers, and if you started using the inverse trig functions to find it, then you'll get numerical answers. For engineering or something, maybe that's good enough, but this kind of problem would normally be on a no calculator portion of the exam, and so I will not give you full credit if you use the inverse trig functions here.